In this video, we're gonna talk about polynomial functions. And first, of course, as usual, we're gonna talk about the definition of a polynomial function. So basically, a polynomial, poly stands for many nomials terms where each term of the polynomial function is a power function. So if we add up all the power, not all, but if we add some power functions together, we come up with a polynomial function. Because remember, your power function consisted of one term only. So now polynomial has many terms where each term is a power function. Now, the term that has the greatest power is going to be called a leading term. And the coefficient of that leading term is going to be called a leading coefficient. And the degree of that leading term is going to be the degree of the entire polynomial function. Okay, so and sometimes when we're given a polynomial function, the terms are all over the place, but if you put them in order from greatest to smallest, then you will be able to determine your leading coefficient, leading term, and the power of the polynomial. So for example, let's take a look at this function 7x squared plus 3/2 x 18 over 5 minus 2x plus 17. So I want you to pause here for a sec and tell me what's the leading term, what is the degree of the polynomial, and what's the leading coefficient in that function. Okay, take a second to do that, and I'm gonna tell you and you check if you got it right. So first of all, the leading term, let's identify the leading term. The leading term here is 18/15 because 18 over, I mean the term with a power, 18 over 15 because that's the highest power. Here we have power 1, here we have power 0 and power 2. This is greater than 3. Okay, so this will be our leading term right here. So this is a leading term. And so if I asked you what would be the leading coefficient, it's the coefficient of that term, so that's going to be 3/2. It's not going to be 7, and it's not going to be 17. The common mistake that I see students make here, they go for the largest coefficient in the entire polynomial. This is not how it works. Once you identify the leading term, its coefficient is a leading coefficient, and its power is the power of the entire polynomial function. So, or power or degree of the polynomial is 18 over 5. Okay, so this is how it works. So the leading term is your term with the highest power. And everything about this term is very important because this term will determine the end behavior of the entire polynomial function. And that is exactly why we're focusing on that term. It's going to become very important. But meanwhile, let's take a look. Identify the degree and leading coefficient of a polynomial function. So for the first one, we have 3 plus 2x squared minus 4x cubed. So negative 4x cubed is a leading term. Negative 4 is the leading coefficient. And 3 is the degree of the polynomial. Now for g of t, we have 5t to the fifth minus 2t cubed plus 7t. So the leading term is 5t to the fifth. The leading coefficient is 5, and the degree of the polynomial is 5. And for the last one, we have h, we have 6p minus p cubed minus 2. So the leading term is negative p cubed. Leading coefficient is -1, and the power is 3, or degree of the polynomial is 3. We're going to say this is a cubic polynomial. So again, I want you to pause and try this by yourself. You're looking at f of x that equals 4x squared minus x to the 6th power plus 2x minus 6. Identify the leading term, leading coefficient, and the power of the polynomial. Now, again, why is this so important? Because your leading term will determine the behavior of the function, the overall behavior. So basically, or the end behavior. Basically, in the middle, the function could do some wiggles, right? Something. But in the end, it will behave according to the leading term. So we see that here the leading term, the function is 5x to the fourth plus 2x cubed minus x plus 4. The leading term is 5x to the fourth. It's an even power function, so it's a U shape going up on both ends, and 5 is a positive coefficient, so the function is still going up, it doesn't rotate. And yeah, so this is what the shape of this function is. So we see that it doesn't start at 0, 0. It doesn't have a vertex there, just like our like basic even power functions did. So like I said, here in the middle, it could do some figures. It could go up and down, it could cross the x-axis a few times, but when we talk about end behavior, it's going to behave like x to the fourth. So let's take a look at this example. It's -2x to the 6th minus x to the 5th plus 3x to the 4th plus x cubed. I know it's kind of like hard to see. I apologize for that, but let me write it down. So again, the leading term here is -2x to the 6th. So again, it's an even powered function with a negative coefficient. So it's going to be U-shaped opening down. And this is what we see. This is the overall behavior. Again, in the middle, we have some wiggle here. You know, the function goes up, goes down, goes up, and then again down. There are some x-intercepts going on, but overall, on the end, as x approaches negative infinity, the y goes to negative infinity. As x approaches positive infinity, the y is negative infinity. So here's an example of an odd power function. So the leading coefficient here is leading term is 3x to the 5th. So again, we see that general pattern. And for this function, the leading coefficient, leading term is negative 6x cubed. So again, it behaves like an odd power function, but flipped because of, or rotated about the x-axis because of negative 6 as a coefficient. So again, in the middle, it's not very predictable yet. We're getting there. But on the ands, it behaves exactly as expected, as the x cubed with a negative coefficient would. All right. So now, describe the end behavior and determine a possible degree of the polynomial function. So first of all, we see that it follows the pattern of the odd power function, right? Odd powered function. And so the end, because as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y approaches positive infinity as well. So this is a very like the pattern for the odd power function with a positive coefficient, positive leading coefficient. Okay, so what about this one? Well, for this one, we have as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y approaches negative infinity still. So the y's go in the same direction on both sides. So this is the pattern for the even powered function. So it's an even powered function with, what about the coefficient positive or negative? Well, since it's turned downwards, we conclude that it has a negative leading coefficient. All right, so this is the end behavior. Okay, and this is the last example that we're going to do in this video. It says, given the function f of x, express the function as polynomial in general form, and determine the leading term degree and the end behavior of the function. So basically what we need to do, we need to multiply these factors through. It's in factored form, so we need to unfactor it to write it in general form. And we could do it two ways. Remember, since there is only multiplication going on, we could just multiply in any order. So we could multiply two binomials first and then multiply everything by negative 3x squared. Or I'm going to actually start by distributing the negative x squared through the first parenthesis. Now, remember here, you can either distribute it through the first group or through the second group, but not both, because then you will be multiplying double by twice. So you, instead of multiplying by negative 3x squared, you will be multiplying by 9x to the fourth. So you distribute it either to the one group or to the second, but not both. Okay, so let's begin. When we distribute to the first group, we get negative 3x cubed, and then multiplying by negative 1 will give us plus 3x squared. And the second group is x plus 4. So the next step would be to multiply two binomials, use FOIL if you like. So we, multiplying the first would give us negative 3x to the fourth. Multiplying the outside will give us negative 12x cubed. Multiplying the inside will give us 3x cubed, and multiplying the last will give us 12x squared. Now we can combine like terms and we get negative 3x to the fourth, okay, minus 9x cubed plus 12x squared. So the leading term of this polynomial is negative 3x to the fourth. So leading term, okay, is here. So the leading coefficient is negative 3. So what did they want us to find? Leading term, degree. Okay, so degree is 4. So it's the power in the leading term, and behavior. Okay, so since we have a even power function, we know that it's going to have this U shape, right? But it has a negative coefficient. So we know that it's gonna be flipped. So if normally, again, normally the even power function looks like this, because of the negative leading coefficient, it's gonna go down like this. And again, it may do something weird here, but for the end behavior, is gonna, as x approaches negative infinity, y will approach negative infinity. And for the right side, the same thing, y goes to the negative infinity. So we could put plus or minus. So the y behaves the same way on the left and on the right side. Okay. So now I want you to try this. And by the way, before we move on, could we predict the power of this function before we actually rewrote it? And the answer is yes, because if we multiply all the x's and all of the factors, okay, we have three factors here, three things being multiplied. We have one binomial, another binomial, and the monomial. So in each of those, we have x to power 1, x to power 1, and x to power 2. When we multiply all of these x's with their powers, we're going to get x to the fourth. And that was the degree of this polynomial. Okay, so this is how you can tell just by, without actually going through this process, you can tell that this is going to be a fourth degree polynomial. So I want you to try this one. Tell me what the degree of this polynomial is going to be by looking at it, and then actually go ahead and express the function as a polynomial in general form and verify that you are correct, and then go from there. Determine the leading term, degree, and behavior. All right. Pause here if you have to, and you will have to. And I'll see you in the next one.